Okay, in terms of modeling data with linear functions, which is one of the main things that we use any function for, including linear functions. Here on page 390, there's some data on there. It says 0, 5, 7, 91 is a point on the left-hand side of this. This is the average premium for household for employer-sponsored health insurance. And this is years after 1999, so this represents 1999 itself, because the data is in terms of years after 1999, so this is the year 0, if you will. We'd have 5791, that's going to be the cost. And then year 9, the cost is 12,680. Okay. So that's the point on the right-hand side of that one. And this is going to represent 9 years after that, so that would represent 2008, if you will. Okay. And so if we're going to find an equation for this line, okay, we are going to need to write an equation in the form of a line, y equals mx plus b. So we're going to need to calculate a slope, and we're going to need to find the y-intercept. Now, one of these is already done for us. This 0 point is the y-intercept. So really, the only thing we have to do is find a slope here. Okay? So just like we did before, if we take our y2, our 12,680 minus 5,791, and we divide it by 9, okay, minus 0, so y2 minus y1 over x2 minus x1, and we go ahead and calculate that. We're going to get 12,680 minus 5,791. We get 6889, 9 on the bottom. So if we divide that by 9, we can get a slope of 765.4 repeating. Okay. Right. And we can write our equation then as 765.4 repeating x plus 5791. And what that allows us to do is that this equation here allows us to make predictions. So if we wanted to predict what the cost was going to be in, say, let's say 2001, okay, 2001 would be 2 years after 1999. We'd plug a 2 in here and do the calculation, and that would give us a prediction. We can also use this outside the data set. If we were to say we wanted to know what is it next year for 2014, well, 2014 would be 15 years after that, so we'd plug a 15 in there, and we'd go to work from there. Now, there's another way to calculate this equation for this line. Your calculator will actually do it if you put in your stat, and if we clear out the data that we have in our stat, in our list 1 and our list 2, if you put those 2 points in there, which are 0 and 9 in the x direction, and in the y direction, if we delete our data from list 2, 5791, 12,680, okay. And then ultimately the calculator will calculate this same exact equation if we do stat calculate and then go down to linear regression. This is going to give us a line of best fit for that data, and as you can see, there's the slope and there's the y-intercept that we expected. Okay? And so we can do it that way as well. Another nice thing to do with your calculator in terms of making predictions is if you put that into your y equals 765.444x plus 5791, and you use your table. If you go to table set and put it on ask, make sure that's on ask, and table set, that's above your window button, and then if you hit table, which is above your graph button, and then you can ultimately make predictions for whatever you want. So like I said, I wanted year 2, which was 2001. Okay, it predicts that the value is 7321.90. And I said year 15, which would be 2014, it predicts 17,273. Okay. And all the calculator is doing is taking 2 and 15 and plugging them there for you and telling you what the y-coordinate is. Okay, so we'll do quite a bit in math with dealing with lines, etc., that relate or that model data. Okay, and this is ultimately the process that we're going to use in any capacity, whether it's a linear model or some other model like a quadratic equation or something else.